Okay, Chan Physics, this is the Unit 2 study guide, and we're going to go really quick through the first page because there are a lot of definitions and some multiple choice possibilities. So the first question talks about inertia. Remember, inertia is Newton's first law, and inertia is the same thing as mass. It's proportional, meaning that the higher the mass, the higher the inertia. The lower the mass, the lower the inertia. So if you have a large inertia and you have the same force, you should have less acceleration. And if you have small inertia, you'll have more acceleration. Okay. Then it says, what if the inertia of the car is the same? That's a very hard way of saying that the mass is the same. So that would mean the mass must be the same, and then they'll both have the same acceleration. All right, question 2. F net has to be equal to 0 when something's at constant speed or moving or not moving. And we can also call that equilibrium. Okay. Question 3 then is a 3-part question or 2-part question. The first part requires you to draw the free body diagram. And so remember, we draw a box, force of gravity, force normal, and then we listen to what they tell us in the question. They're saying that we're moving 250 to the left, 780 to the right. Okay, and they gave us this big gigantic number, 12 million grams. And we won't do this to you during the test, but then we had to convert 12 million grams to 1,200 kilograms, 1,200 kilograms. So the first question is, what's the net force? Remember, who wins and by how much? So we just take 780 minus 250, we get 530. All right, now in the 4-column method, we had the mass. We figured out the F net from the question, and now they're asking us to find the acceleration. So we have 2 out of the 3. We should be able to write the equation, put in 530 equals 1,200 times A, get rid of the 1,200 and get A. Okay, so that's 2-part question with the same set of facts. The next question is next 2 questions are about weight. Remember the definition of weight is mass times gravity. So remember we came up with 2 different ways. So if they're asking you to find the weight of something without any other information about how big the Earth is or the radius, you'll use weight equals mass times gravity. First one's really simple. Put in the numbers and multiply them out. The second one, they give you the weight and they want you to find the mass. So when we do the 4-column method, 392. Now some people might be asking me, why did you get negative? Okay, negative. It doesn't say negative here, Mr. Block. Well, remember, a negative weight is a downward force. Weight is a downward force, so it's negative. If you didn't put a negative here, you would get a negative mass. And there's no such thing as a negative mass. Mass means the amount of stuff, and so you can't have less than 0 stuff, okay? So that's that part. I'm going to pause real quick, and we're going to go to page 2. Okay, so there wasn't much of a break there for you guys watching at home. So the second question or second page starts with this idea of between mass and weight right here. So remember, mass is the amount of stuff. And so let's say I had a pipe, like a metal pipe that I would use to put together a faucet, right? And since mass is the amount of stuff, they say if an object's at Earth, how would it compare to the amount of mass on the moon? If I take this pipe to the moon, it's the same pipe. It's got the same amount of stuff. And so it's not less weight. It's the same amount of mass. And my pens are all... So it's the same mass, right? And so that's the same. But it says if you measure weight of the object on Earth, how would it compare to that measured on the moon? So if this is my Earth and this is my moon, right, we would think, well, this object will pull on that pipe harder than this one, right? And so if we just look at the idea, right, it will weigh more on the Earth. Right? It's going to weigh more on the Earth. But even if we were to say, okay, let's do this equation, right? Here's Earth, and here's the moon. And weight is mass times gravity. Right? And let's just give our object a mass of 10 kilograms. Right? Well, if the weight on the Earth will be W equals 10 times negative 9.8, and on the moon, weight will equal 10 times negative 1.6. So this is negative 98, and this is negative 16. So, right, weight, it will weigh more on the Earth. Okay. All right, define mass. Mass, right, the amount of stuff is the easiest way. That's like how they teach you at the beginning. But how about the amount of matter? Okay, and either one of these definitions, it doesn't change when we send it off to the moon. Define inertia. Okay, the one that we've been using is the resistance to change in motion. Okay, and another way to say this is an object at rest stays at rest, an object in motion stays in motion. Remember, Newton's first law is the law of inertia. And that Newton's first law is an object at rest stays at rest, an object in motion stays in motion. Okay, sorry, lost the camera there for a second. All right, so now we're going to move on to question 8. It says a sled with a mass of 30 kilograms is pushed around the floor with a force of 50 newtons. The sled accelerates at point 2. What's the friction force? Remember that we said that this was the hardest question on quiz number 2. We draw the free body diagram. We know that there must be an applied force. That's what they're saying is 50. There must be a friction force of some amount that we don't know. Okay? So when we put together the 4-column method in this problem, we say, well, the mass is 30. The force is 50. And the acceleration is 0.2. Okay? So right away, we should know that we've made a mistake if we think that this is going to solve the problem for us, because all 3 of them are there. And if we give all 3 of them there, there's nothing to solve for. Right? So the force of 50, that's there. But what moves this object is not the 50, it's the net force. They must be asking us to find the net force. That's the unknown. Okay, so if you ever get a chance where there's 3 things and you're like, oh, I can't solve for anything, that would probably tell you that you're not thinking correctly, that F net equals mass times acceleration, Newton's second law. And so F net is equal to 50 times 0.2. And 50 times 0.2 is 10. 10 newtons. All right, so F net is 10. So if we write the equation, F net equals 50 minus the force of friction. So 10 equals 50 minus x. So x is equal to 40. So the friction force is 40. Okay? And a lot of you guys ran into that in the quiz where you had all 3 and you're like, oh, I don't know it. You have to remember that this F net is the thing that you're going to find from that equation. All right, calculate the normal force the floor exerts on the sled. If we look at this, the force of gravity is down. Force normal is equal to that. All they're asking us to do is to find what the force of gravity is, because the normal force will be opposite that. What's the force of gravity? W equals mass times gravity, or W equals 50 times negative 9.8. Okay? Put that in our calculator. 50 times 9.8 is 490. So the normal force must be 490 up. Okay? I'm going to pause it real quick and we'll go. Okay, we're moving on to question 9 on page 3. And all they're talking about is a skier being pulled by a boat causing them to accelerate. So if it says always draw the free body diagram. So I'll draw the free body diagram. The person has a mass, their gravity, they're on Earth. There's a normal force. There's a force. A lot of times people might call this a force applied. I think agree. But we can also call this the tension force, the force of the tension on the rope. The rope is the thing that's pulling our skier. So either one of these would work. Okay, it doesn't really matter what we're calling it. And they don't tell us that force, right? But they do tell us there's a friction force of 78 or 76. 76. All right. So how do we go about finding the tension? Well, if we put in the information F, A, and N, they told us that there's 80 kilograms. They told us that she's accelerating at 1.8. Remember that we can always find F net with that equation. So F net equals mass times acceleration, or F net equals 80 times 1.8. All right, 80 times 1.8 is 144. So the F net is 144. So when we think about this force right here is winning by 144. Okay, and so if we look at this, F net equals the applied force minus the friction force. So 144 equals the applied force minus 76. How do I solve for this? Well, I have to add 76 on this side, add 76 on this side, and I get the force applied is equal to 220. Okay. A lot of us will miss that this is a two-part question because we'll think we're solving for the applied force when we're really solving for the net force, and then we have to put it into our free body diagram. Right? Calculate the upward force. This is, again, they're just asking you guys to find the weight. Right? Weight equals mass times gravity. Or weight is equal to 80 times negative 9.8. That will get us the force of gravity. The normal force, or the force that the water exerts on a person, will be the exact same number. So 80 times negative 9.8 is 784 newtons. Okay, that's question 9. Question 10. They're talking about an inclined plane, and the reality is that inclines in this unit do nothing different. We just have to realize that we're just tipping things forward. And so they're going to give us a 60 kilogram skier with an incline with an acceleration of 5.1. What's the net force? They want to know the net force right there. All right. We don't care how much the tension is. We don't care how much the friction force. They're just asking us for the net force. And so this question is really just a four-column method. Mass is 60. Acceleration is 5.1. F net, we don't know. And so F net is equal to mass times acceleration, or F net is equal to 60 times 5.1. Okay, 306. All right, if we were taking a AP class, we would we'd be looking at all these different things, and we'd teach you sines and cosines, but thank God you don't have to know that stuff because it's a lot of fun. We'd take a long time. Okay. All right, for each of the following, determine the forces are balanced or unbalanced. A dog runs at a constant speed. If we're at a constant speed, we must be balanced. A swimmer accelerates down a pool lane during a race. We've got an acceleration, must be unbalanced. An object has a net force of 0. That's balanced, right? A book sits on the table. It's sitting, it's not moving, it's not accelerating. Balanced. A teacher walks around the room at a constant speed. Constant speed should tell us that we're balanced. You push the brakes on your car to slow down. That's a negative acceleration. That's unbalanced. An object has a non-zero net force. That's a definition of unbalanced. Okay? All right. And then the last one, I'm running out of time. I think I got 15 seconds. A book is at rest at a table. Draw the free body diagram. Are we on Earth? Yes, there's a force of gravity. Are we on the table? Yes, there's a force normal. It doesn't look like there's anything else, so those must be equal. Sorry, let me get that on there. And that's the free body diagram. Okay, I'm going to hold off right here and post this. This will be the first